Good evening everyone here. I welcome you to NEET World. So this is our session 3 on structure of atom, right? I hope you have followed previous sessions on the structure of atom, and today we will be discussing numericals related to the structure of atom. Especially here we will be focusing on Bohr's atomic model numericals, because last class we have discussed Bohr's atomic model completely using the PYQs also from EAPCET, right? So today we will be continuing the same session with PYQs of Bohr model, and after that we will be looking into de Broglie wave equation and quantum numbers and related questions also, because these are the few important topics that to be focused for EAPCET, right? Let's look at the question number 1 here. See, yesterday, just look at the formulas. Yesterday we have discussed all these formulas, right? Hope you have seen the last video, right? Right. So this is a formula again for time period and all. Yeah. So and also spectral series also we discussed. Hydrogen atom, if we observe the hydrogen atom atomic spectra, we will be having series of lines. Okay. So if the any line, if the transition is taking place from any higher state to first ground state, first energy level, we can say it as that belongs to Lyman series. See, from any higher energy levels to first energy level, we can say those lines will be Lyman series lines. If it is from 2 to 1, first line. If it is 3 to 1, second line. 4 to 1, third line, like that. And all the Lyman series lines are appeared in UV region, okay? And for Balmer series, it will be appeared in visible region. For Paston, it will be IR, and for bracket, Fund, Hamfer, all these are IR, or you can remember this is near IR, mid IR, far IR, in that way, okay? But all these lines from 3 Paston series to Hamfari, all will be seen in the IR region, okay? Right. Yeah, so anyone in the chat box? Yeah, let's discuss few questions here. All this discussion is done in the last class. This is about de Broglie wave equation. Before going to that, let me ask you 1 or 2 questions related to the spectral lines. See, we have a question from 2022 paper. Look at the question, what this says. The total number of spectral lines observed when an electron returns from 6th shell to 2nd shell in the hydrogen atom. Very simple now. See what I told you, number of spectral lines. Number of spectral lines. You can use the traditional method like following, like taking the lines n equals to 6 to n equals to 5, 4, 3, 2, and you can count like in this manner also. Electron transition can directly come from 6 to 2, or it can come from 6 to 3, then 3 to 2, like this also you can do. Or simply I told you one formula to calculate this. So follow that method. So follow this method. See, number of spectral lines is equals to 1 by 2 into n2 minus n1 multiplied with n2 minus n1 plus 1. Okay. So we have seen the questions in the last class also based on this. Just tell me 1 by 2. What is the n2 value given? 6, and n1 is given as 2, right? So here also 6 minus 2 plus 1. So we'll get 4 by 2 means 2 into, so this will be 5 there. See, 4 plus 1, 5. So we'll be getting 10 lines. How many spectral lines will be seen? 10 lines. So option B will be perfect answer for this question. Hope this is clear. Okay. Now tell me what will be the answer when electron transition is taking place from 5th state to 1st state. It means 5th energy level to ground state. Number of possible spectral lines observed is how many? So this is my question. So if you know the answer, just tell me in the chat box. So this is your question. 5th orbit to 1st orbit, electron transition taking place. So how many possible spectral lines will be observed? Okay. Next. So what are the limitations for this Bohr's model, Bohr's atomic model? What are the limitations we have? Okay, because we may expect questions from limitations also, right? So the first limitation here, it is failed to explain for multi-electron systems or multi-electron atom. Bohr model is applicable only for single electron system. So single electron system containing species only, like hydrogen atom, helium +1 or lithium +2, beryllium +3. So this kind of species only follow, or this Bohr model will be applicable. Okay, and inability to account for fine spectra. Okay, and also it is failed to explain splitting of spectral lines in presence of magnetic field and in presence of electric field. So these phenomena are called as Zeeman effect and Stark effect. If spectral lines are splitting in presence of magnetic field, it is called as Zeeman effect. See, just now we have seen these are spectral lines, possible number of spectral lines based question here. See, these spectral lines are there now. So these spectral lines splitting takes place in presence of magnetic field as well as in presence of electric field. So the splitting of spectral lines in magnetic field is called as Zeeman effect, and in electric field called as Stark effect. So these phenomena or these effects were not explained in Bohr's atomic model. Therefore, this is one of the drawback. Okay. Then next, it contradicts Heisenberg's uncertainty principle. Okay, because it suggests like what we know, suggests precise orbits violating quantum mechanics. See what Bohr model says. So if electron is present at particular place at a distance r from the nucleus, we are saying all these things. So we are having a precise orbit here. So which is contradicting the Heisenberg's uncertainty principle. What he says, we cannot able to find exact momentum and position of a moving particle simultaneously, right? So this is contradiction to our HUP, Heisenberg's uncertainty principle. Okay, and next, it ignores wave particle duality. Okay, and treats electron as a particle. Okay, this is one more drawback of Bohr's atomic model. Okay, then next, let us look into this question once. Just tell me, based on spectral lines we have discussed till now. So what could be your answer for this? Tell me. Very simple question in NEET exam. Which are the following series of transitions in the spectrum of hydrogen atom falls in visible region? So which one will falls in visible region? We know it will be like Lyman, Balmer, Paschen. These all things are seen now. So Lyman falls in UV, Balmer falls in visible now. So what will be your answer? Balmer series. So option 2. Whereas Lyman will be in UV, Paschen, bracket, all these things will be in IR, right? Hope this is clear. Next. And could you answer this from JEE Mains? Again same question now. I mean similar concept, everything is same here, but asking in different exams. Okay, we have seen same concept based questions in JEE, NEET and EAPCET. See, this is from JEE paper. See, Lyman series in UV. Okay, so next, Lyman Balmer is in visible. Okay, and Paschen in IR. Okay, and this fun series also IR. That's it. Based on this, A2, where do we have A2? Yes, A2s are there here, and B4 is there only in third option. So option C will be your answer for the question. Hope this is also clear. Yes, if it is clear, just let us move forward with few more questions. Look at this, we have a de Broglie wavelength question. Simple. First of all, understand de Broglie's hypothesis. So what he says is, see, de Broglie hypothesis, consider like microscopic particle like electron have dual nature. What it is said? It has dual nature. So what is the dual nature here? Particle nature and wave nature. So based on these, we can have two formulas. Okay, from classical mechanics, E equals to mc square we can take, and from quantum theory we have E equals to h nu right now. So using these two things, we got a energy formula. I can write like this: E equals to mc square, which is also equals to h nu, that is hc by lambda, right? So using this I can say lambda is equals to c square. So I can write h by mc. So this is c is the speed of light, this is called like speed of light I am saying now, yeah, light. Okay, this is in case of light. Now in case of like any microscopic particle, why I am using microscopic particle? Because this de Broglie's hypothesis applicable only for microscopic system, it won't applicable for macroscopic systems like big balls, I mean whatever the particle you are considering. Okay, so now what I am saying here, for microscopic particles like electron, I can write lambda equals to h by mv. Okay, so here h, Planck's constant, you can say 6.626 into 10 power minus 34 joule second, and mass whatever the particle, if it is electron you can take mass of electron, and v is the velocity of that particle. Okay, this is what we need to consider here. Hope this is clear. Now let us see one question for making it more clear. Okay, yes, yeah, look at this question we have. Yeah, look at this question. A de Broglie wavelength of an electron traveling with 20% of the velocity of light. See, what is the velocity of that electron? They have mentioned here, velocity of electron is mentioned as 20% of velocity of light. See, velocity of light 3 into 10 power 8 meter per second I am taking. So 20% of it means, can I write like this? Yes, we can write. So what is the velocity of electron we are getting from here? So it will be 2 to the 6 into 10 power 7 meter per second. That's it. This will be the velocity of electron we got right now. Hope this is clear. See, 20%, 20 by 100 into velocity of electron 3 into 10 power 8 meter per second. So by simplifying we will get 2 3 is 6, and this will become 9 by 100 means 7. I can say 9 by 10 power minus 2 means it will become 7. Hope this is clear. Okay. Now what they are asking, de Broglie wavelength, lambda equals to h by mv we have. So this is 6.6 2 into 10 power minus 34 joules second by, and what about the mass of electron given here? 9.1 into 10 power minus 31 kg into, and velocity is given is how much? 6 into 10 power 7 meter per second. Okay, look at this, joules is a, you can write this joules as kg meter square second inverse square or per second square you can say. Okay, this is what you can write. So from this I can remove, in the place of joule I can remove this kg and meter square, this is second and second inverse square. Okay, we can remove. So we are having only units in terms of meters. So now our answer is also in terms of meters now? Yes. So it means we are almost doing it correct only. So this I can write 1.1, and the next this will be 10 power minus 3 I can write. So we got 1.1 by 9.1 into 10 power 7. 10 power 7 I am writing. So this can be written as, see, 1.1 into 9.1 into 10 power minus 10 I am writing. Okay, see, all options are having 10 power minus 11. So what I can make here, simply 1.1 I can write 11 now, right, 11 into 10 power minus 11 by 9.1. So you just simplify this, this will be almost one time 1.2 light. Okay, right. So 1.2 into 10 power minus 11 meters. Yes, we got the answer. Look at the options. Where do we have? See, option B will be perfect answer. See, 1.2 into 10 power minus 11. Hope this is also clear. Yes guys, if this is clear, just click on the like button. And now I am giving you one question. Just answer me the question. The wavelength of a cricket ball moving with having mass 20 grams and moving with a velocity of 50 meter per second. 50 meter per second. So just tell me lambda here. Very simple now. So lambda means h by mv you can take. H you have 6.62 into 10 power minus 34 joule second. And what is the mass given? Mass is given as 20 grams. You can take 20 grams. But SI units joules here we have. So write it in kg. So 20 into 10 power minus 3 kg I can write in place of grams. Right. Multiplied with what is the velocity given? 50 meter per second now. So 50 meter per second. That's it. You can simplify this. You will get your answer. And just try this question and let me know your answer in the chat box. Okay. Right. Let's move forward with few more questions. Yeah, one more question in the similar way. You just try this question also. Again, this is a question purely from EAPCET. Now you can try this question and tell me your answer in the chat box. Anyone in the chat box? Guys, it's really useful if you attend the classes regularly without missing the sessions. Okay, now try this. Next here, one more. This question we already did just now. Can you answer this? Two particles of masses having m and 2m have equal kinetic energies. The de Broglie wavelength are in the ratio of, see, very easy. This is one more model question, that's why I am choosing this. See, lambda equals to h by mv we got right now. So we know mv means momentum, right? So they are asking here in terms of kinetic energy. So we know kinetic energy formula K equals to half mv square. From this I just remove this mv and I wanted to substitute with kinetic energy. So what I can make here, 2 into, I am multiplying both sides with mass into kinetic energy will be equals to mv whole square, right? So mv whole square we got here. So mv will be equals to root over 2 km. So where k represent kinetic energy, m is a mass. Okay, right. In the place of this mv I can substitute that lambda will be equals to h by root over 2 km, right? Hope this is clear up to here, right? What they are saying, wavelengths are in the ratios. Okay, it means you take it as ratio here itself for making it comfortable for you. Lambda 1 by lambda 2 you take. Okay, so two particles of mass m and 2m. So this is particle 1 wavelength, particle 2 wavelength. Okay, and here for particle 1 h by root over 2k, m for particle 1 is normal m only, mass for particle 1 is m, and for particle 2 it is 2m, k m into 2m they are saying. Okay, that's it. We are almost done here. See this one I can write, this h are constant, remove that, and this will be root over 2km, and this will become how much, you just check here, it will be, it goes to the numerator now. So you can write root 2 into root 2km. So you can remove these two things. Yes, we got almost our answer we got. Here lambda 1 by lambda 2 is equals to root 2 we got. Okay, yes. So we can simply say this as root 2 is to 1 now. Yes. So we have option 4 as our answer. Hope this is clear, right? If this is clear, just say clear in the chat box. Yeah, we have option 4 as our answer for the question, right? Yeah. I hope you are doing your preparation parallelly along with your like I can say JEE if you are really a serious aspirant for JEE, and if you are a serious aspirant for NEET, yes, I suggest you to prepare your JEE NEET exams only as of now. For example, if you are preparing for JEE, till phase 1 you just focus only on your JEE exam only, okay, till your January end. So once after completing the session, you might be having your IPE exams, right? Yes. So during your IPE exam, again focus more on your IPE. Along with that, just have a touch on EAPCET exam, because you won't lose your problem solving skill. I mean, you can improve, you can manage a time period. I mean, you can improve your problem solving, or I can say the time you are taking for each question can be improved when you solve this kind of questions. EAPCET questions are relatively easier when we compare with the JEE, right? In terms of chemistry subject, right? Okay, so that you will feel more confident when you solve this kind of questions. Okay, do not ignore EAPCET again. Okay, so once after completing your IPE exams, I suggest you to start your preparation for phase 2, and along with that, parallelly you focus on your EAPCET preparation also. Preparation means nothing here. Anyways, you are preparing for JEE, right? So whatever the extra topics we have, for example, in JEE we do not have solid state and surface chemistry is not there in JEE mains, okay, but we have it in the EAPCET. Okay, like this there are some chapters which are removed from NCERT, I mean in JEE and NEET syllabus, but which are they are there in this EAPCET exam. So also cover those topics if you are really expecting a good rank or hoping for a good rank in this EAPCET 2026. Okay, see, just try to score, see, even if you start now, if a fresher is starting, I mean a just IP preparing student is starting now, so try to score at least 80 plus marks, so that you will get a good seat, a good college you can expect in EAPCET. Okay, and those who are really working hard for their JEE and NEET, so you just expect more than 100 marks, so that you will be in a top college in, if you want to join in your local area through EAPCET. Okay, yeah, so this is about normal approach towards your preparation. Okay, right. Yeah, next one more important topic here in this structure of atom is quantum numbers. So what is this quantum numbers here? See, quantum numbers help us to give the exact position or exact address of a particular electron. Okay, see, quantum number is something like, it is a set of 4 numbers with the help of which we can get complete information about the electrons in an atom, that is location and its energy and in which type of orbital it is present, and what is the shape of that orbital and what is the orientation. Everything will be getting looking at these quantum numbers. So what are the quantum numbers we have? One is principal quantum number and azimuthal quantum number, and angle, like next to it, magnetic quantum number and spin quantum number, or we can represent the MS. So these are the 4 now. So these first 3 quantum numbers we have got it from solving Schrodinger wave equation. What is that? By solving Schrodinger wave equation we got first 3 quantum numbers. Okay, this is extra added here. Okay, they will ask, so which of the following quantum numbers are like obtained from this Schrodinger wave equation? Principal quantum number, azimuthal quantum number and magnetic quantum number are from Schrodinger wave equation. You can remember this. Okay, next. So now what is the use of principal quantum number? It says, or it tells about the energy shell, like energy, I mean in which energy shell or which energy level that electron is present or it belongs to. Okay, so now the principal quantum number values are given as 1, 2, 3, 4, so on like this. Okay, and see, for hydrogen like species, it means what? That Bohr model we discussed now, there I told you hydrogen and hydrogen like single electron system like helium plus lithium plus 2. For this kind of systems, the value of energy or the order of energy of the orbitals depends only on n value. Okay, so just n value will decide the order of energies in case of single electron system. For example, I am giving you 1s, 2s, 2p, next 3s, 3p, 3d, I am giving it like this. Now what is the order of these orbitals, they will ask. So tell me what is your answer. So if it is multi-electron system, we need to look for principal quantum number as well as azimuthal quantum number L. But when it is a single electron system like this, the value depends just on n value only. If n value is same, their energies are also same. Okay, look at this, 1s, 2s. So greater n value, greater is the energy. If n value increases, energy also increases. We have seen even in while studying Bohr's atomic model. See, if this is a nucleus, around we have orbits in which electrons are revolving, we have studied. So this is n equals to 1, n equals to 2. As we move away from the nucleus, what happens? Its energy increases. So n value increases, energy also increases. So what will be the order? Like this, 2s, 2s, 2p, same n value now, so same energy for single electron systems. Okay, and here it will be like this, this is equal, this is equal. If I say 4s, 4s is greater than 3d, like this. This is a way of arranging them in the increasing or decreasing order of orbitals, okay, for single electron system. I will tell you for multi-electron system, but this is about single electron system. Okay, right. Let's move forward with few more examples. See here, for single electron system, it just depends only on n values. Okay, for multi-electron system, it depends on both principal quantum number as well as azimuthal quantum numbers. Therefore, the maximum number of electrons present in any shell. In any shell means what? In an nth level, how many electrons are present? They are saying. So that will be equals to 2n square. Okay. So because number of orbits present in a particular shell or nth level will be n square. See, for 2 second energy level, if I take n value equals to 2, I can write a 2p, I can write 2s as well as 2p, right? So I have one 2s orbital and I have 3 2p orbitals. So total how many orbitals we have? 4 orbitals are there. Right now 4 orbitals are there. That is nothing but 2 square. N square gives number of orbitals in an nth level for single electron system. Okay, this is a JEE advanced question also based on the single electron system. Okay, and in each orbital we can able to accommodate 2 electrons. Therefore, maximum number of electrons present in any shell is how many? 2n square. So for example, in second shell, how many electrons can be accommodated at maximum? Okay, so 2 into n square, 2 square means 4, that's it. So 8 electrons will be accommodated. So 2 in s orbital and 6 in p orbitals, 2p orbital. Therefore total 8 electrons can be accommodated here. Hope this is also clear, right? Next. Okay, so we have studied about principal quantum number now. So next, here we have azimuthal quantum number or angular quantum number, I can say. Quantum number indicated with symbol L. Okay, so this is also considered as subsidiary quantum number. Okay, so now for a given n value, always L will be less than n. It means for a given n value, for if n value is 2, so L can be 0, 1. It cannot be 2. Always L value should be lesser than n. Okay, so for a given n value, L varies from 0 to n minus 1. Okay, so for example here, for a given n value I am saying n equals to 3. So L can be 0, 1, 2. Okay, if the value of L is 0, then we can say this is s orbital. If value of L equals to 1, then can be considered as p, and if it is 2, it is d. Okay, like this. Okay, So by looking at the n value, we can see which type of orbitals, which type of subshells we have here. Okay, like SPD, by looking at the n value we can predict. Okay, hope this is clear. Yeah, next. So what I told you, for a multi-electron system, energy of orbitals, I am saying energy of orbitals depends upon n plus L value. What I am saying, energy depends upon n plus L values. Okay, so for example I am writing for one S, 2S, 2P, 3S, 3P, 3D, 4S, like this I am writing 4S, 4P, 4D, okay, 4F, like this we are writing. So if we look at these, for single electron and for multi-electron, what will be the energy order they will ask? Very simple. For single electron, just look at the n value, just n value, greater n value, greater is the energy. Okay, for multi-electron system, look at n as well as L. Okay, so just look at the n plus L value, greater the n plus L value, more is the energy. Okay, more energy. Okay, next, if some cases n plus L value is same, in that case if n plus L value are same, consider higher the n value, greater the energy. Okay, hope this is clear what I am saying. Now tell me here, how can I arrange them for this single electron? 1s least energy, 2s, 2p will be having same, then next 3s, 3p are having same, and 3d also, then next 4s, 4p, 4d, 4f, all of them are having same energy in case of single electron. But in case of multi-electron system, n value is 1, for s orbital L equals to 0, here also 0, p 1, L value for s is 0, for p it will be 1, okay, for d it will be 2, for s it is 0, again for p it is 1, for d it is 2, for f it is 3. Okay, these are the L values I have written here. Okay, now check here n plus L value, n plus L value here, n plus L value here will be how much? N plus L value is how much here? 1 plus 0, that will be 1, and here 2, this will be 3, this will be 3, again this is 4, and this is 5, this is 4, and this is 5, this is 6, this is 7, like this. So now greater the n plus L value, greater is the energy. So 4f is having maximum, so write 4f maximum. After that, okay, or go from minimum if you want. So which is having minimum value here? 1s, this is the least energy. After this 2s, the next here and here 3 and 3. So what to consider? I told you n plus L values are same, then what I told you, greater the n value, greater is the energy. Okay, it means 2p here, then next 3s. Okay, and after this 4, 5, 4. So what we need to consider? 3p here, n value is 3, so 3p, and after this here it is 4, so write 4s is lower energy than 3d. Okay, and after this 4p, 4d. So what it is? 4p, and the next 4d, next 4f. This will be the case for multi-electron system, and this will be for single electron system. Okay, so this, if the orbitals are having equal energies, see this 3s, 3p, 3d, subshells are having equal energy now, so this can also be termed as degenerate orbitals, degenerate orbitals, degenerate. You can remember this word. Degenerate means they should have same energies, that's it. Okay, right. Next one here we have spin quantum number. Okay, and before this what we will be having? Azimuthal quantum number over. Next, magnetic quantum number. So this magnetic quantum number indicated with symbol ML, okay, it gives orientation of orbitals, okay, orientation of orbitals. So for a particular L value, ML values lies from minus L to plus L, okay. For example, I am saying L value equals to 0, ML will also be 0 only, ML will also be 0. For example, L equals to 1, so then ML values will be equals to minus 1, 0, plus 1. This is the case. L value 1 means p orbital now, that's why we have 3 p orbitals, okay. One is minus 1, 0, plus 1, okay. And similarly, if I have L equals to 2, you can say this is d orbital. So if L is 2, ML will be minus 2, minus 1, 0, plus 1, plus 2, like this. So how many orbitals we got here? 1, 2, 3, 4, 5 now. So 5 orbitals you can take, okay. And each orbital accommodate how many electrons? 2 electrons. So I hope this is clear. For a given n value, L value will be always smaller, and for a given L value, ML values lies from minus L to plus L. These are the some important key points that should be remembered, okay. Next, see here I am telling you one formula here. Number of orbitals in a subshell will be equals to 2L plus 1. What is this 2L plus 1 formula? See, simple ma. Look at this. For example, P subshell we have. In this P subshell, how many orbitals are there? This is the question. See, how many are there? 1, 2, 3 are there, no? So you will get directly from this formula also. 2 into L value is 1, put here plus 1. So how much? 3. Similarly, number of orbitals in a subshell having L is 2. L is 2 means D na. So you can say 2 2s are 4 plus 1. So there are 5 orbitals. What are those 5 orbitals? Minus 2, minus 1, 0, plus 1, plus 2. Hope this is clear. Now I am giving you L equals to 3. How many d orbitals are there? How many f orbitals are there in that? Tell me. Total number of orbitals present in this subshell. Okay, L3 means F subshell now. In F subshell, how many orbitals are there? That is a simple question I am giving you. Just tell me in the chat box. Okay, right. Let us move forward here. We have one more quantum number called spin quantum number. So this says us about the orientation of electron. So electron can be oriented in the clockwise direction or in the anti-clockwise direction. Okay, right. So for each spin, we are indicating as plus half and minus half. So you can use any way. If for example, if you are using clockwise plus half, anti-clockwise will be minus half, or vice versa you can use. Okay, hope this is clear, right. Now what is the using this spin quantum number? What is the use of looking at this spin of an electron? We can able to say whether a given substance is diamagnetic or paramagnetic. It means whether it is magnetically active or not. This can be considered here. For example, I am saying there is an electronic configuration of 2s2, 2p, 2p, 4 I am saying. So now how many electrons are paired here? Just look here, 2s, 2p. So 2 electrons are like this, 1, 2, 3, 4 electrons are there. So 4th electron will be filled here. So 2 electrons are there which are unpaired right now. So number of unpaired electrons are 2. In this case, you can find spin only magnetic moment for this particular species as root over n into n plus 2 Bohr magnetons. So what is the n value here? 2, right? So it can be 2 into 4 4 magnetrons. So root 8, that will be around 2.85. Okay, so this is the spin magnetic moment value for this particular species. And now I am giving you what is a magnetic moment value for Mn plus 2 electronic configuration, for manganese plus 2. How many valency electrons are there, and in that valency electrons how many are paired, how many are unpaired. So just take number of unpaired electrons. Okay, number of unpaired electrons you take. For that you can apply this formula. You will get your S, spin magnetic moment value. Okay, that will be your answer for the question. Okay, hope this is clear, and if any confusions are there, let me know in the chat box. Next, can you answer me this question? 4d 5p 5f 6p orbitals are arranged in the decreasing order of energy. Tell me what is the correct order here. So just now I told you to look at their n plus L value, right? See, if in the question they mention particularly for single electron system or hydrogen like system, then only you consider it for that like hydrogen atom, like what I told you, for hydrogen atom only depends on n value, right? If they haven't mentioned, you take this n plus L, Bohr-Bury rule we can say. Okay, so what is the answer for this question? 4d is there, 5p is there, next 6p is there. Okay, so for this what could be the answer? 6p and 5f. So n value here for p, this is n values are 4, 5, 6, 5, like this you can write, and L values are, n values are like this, and L values are, for D it will be 2, right, and for P it is 1, for P again 1, for F again here it is 3. So total sum is how much? 6, 6, 7, 8. So greater value for 5f, so greater is the energy for 5f. Next, 6p having 7, so 6p here, and between these two greater, see, n plus L values same, n plus L values are same. So what to consider here? Consider greater the n value, greater is its energy. Greater n value is for this one here, you can check, so 5p, and least is for 4d, that's it. This will be the order. Okay, where do we have this kind of option? So we have option 1 as our answer for the question. Hope this is clear, right now. Next, which are the following series of transitions in the spectrum of hydrogen atom falls in the visible region? Yes, visible region, which one? Again we have seen already this type of model questions we have seen. Okay, so Lyman, UV, Balmer, visible, that's it. Okay, right. Let me show you a few other questions also here. Like based on yesterday's discussion, can you answer me this question? Can you answer me this question? Radius of second Bohr orbit of beryllium plus 3 is x. Then radius of second Bohr orbit of helium plus ion is dash in terms of x. Okay, so what is this value here? You can get me or give me your answer in the chat box. Okay, just try this. What could be the answer for this? See, simply you can use radius of an nth orbit for hydrogen like species as 0.529 n square by z right now in angstroms. Okay, so since it is a ratio, you can say Rn is directly proportional to n square by z. Okay, so R2 of beryllium plus 3 by R2 of helium plus 1 is equals to, what is the n value they have mentioned? R2, okay, 2 square 4. What is the z value for beryllium? It is 4, okay, and here for helium R2 2 square 4 and n value z value for helium is 2, that's it. Okay, so you will get here, you can write, avoid confusions, and you can write like this, remove this, you will get 2 here, right. So we are almost done. So R2 of Be plus 3 is equals to 1 by 2 times of R2 of helium plus 1, right. So what this giving in the options, I mean here R2 of beryllium plus 3 is x, so this value is x. Then our R2 of helium plus is how much? 2 times of R2 of beryllium plus 3, right now. So that is x into 2. So this is 2x will be your answer for the question. Hope it is very clear, right? Yeah. Let me give you one more question. Answer me for this. The radius of first Bohr orbit of hydrogen atom is A0, then radius of third Bohr orbit of lithium plus 2 ion is how much? This will be the question I am giving for you. So just try it and tell me in the chat box. Okay? Anyone here to answer this? Yeah. In a similar manner, we have the questions for energy also. See, if energy of, because most of the EAPCET questions are in this model only, like ratio. If the energy of if the energy of electron in the first Bohr orbit of hydrogen atom is x, then what could be the energy of electron lies in the second Bohr orbit of helium ion in terms of that x. So these are the questions which we are seeing more frequently in the structure of atom EAPCET exam papers. Okay, and I am giving you one question in that manner, so you can use this. So energy of first energy of electron in first Bohr orbit of hydrogen atom is x, then energy of electron in third Bohr orbit of lithium plus 2 ion. Okay, so in terms of x, you should answer me this in the chat box. And where can you get the answers for this? You just try this. If you are really unable to answer this, you just go and watch my previous session. Then definitely, I mean last session, definitely you can able to do this radius based question, velocity based question, energy based questions. Okay, okay, and you can get me the answer in and give me the answer in the chat box. If you are, even if it is wrong, I am going to give you the correct answer in the chat box if you try this. Okay, right. These are the 2 homework questions I am giving you. And you know, in a similar way, they may also ask ionization energy value also. See, there is nothing like difference in ionization energy and total energy. So total energy is there now, you take ionization energy equals to negative of total energy formula. It means we are writing now total energy formula is minus 13.6 n z square by n square electron volt per atom we are taking now. So apply negative to that, so that it will become positive 13.6 z square by n square electron volt per atom. This will be the formula for finding ionization energy. Okay, use this formula, you will get the ionization energy based questions also. Okay, hope you have watched this session completely, and if you have any queries, you can just write me in the chat box. I will be looking into it and I will be covering them in the upcoming sessions. Okay, yes. So stay connected with this NEET World channel. Okay, so yeah, thank you for watching. Thank you.